All right, let's look at how to use derivatives and integrals with power series. The goal for this part is going to be to find a power series for this function here. Now, don't make the mistake of saying that this is 1 minus x squared. You can't just put the x squared inside. So how can we get this series? Because it's not quite the right form. But notice this: if we take the derivative of this, the derivative of 1 over 1 minus x. I'm sorry, we're not taking the derivative of this, we're taking the derivative of this function. Where did it come from? Well, it's the one that just happens to give us the thing we want here. If you take the derivative of this, you've got, let's see, 1 minus x to the negative 1. So you get minus 1 minus x to the negative 2. And then chain rule, but chain rule says multiply by negative 1. So we get 1 over 1 minus x squared. All right. So that tells us that this function here that we want is the derivative of 1 over 1 minus x. Now we know 1 over 1 minus x is the power series that starts with 1 and then multiplies by x every time. Now, let's take the derivative of this. If I take the derivative of this side, and I take the derivative of this side over here, let me slide it down a little bit. What this is going to give me on this side, we just saw up there, this gives me 1 over 1 minus x, quantity squared. And over here we can do the derivative term by term. So derivative of 1 is 0. Derivative of x is 1. Derivative of x squared is 2x. Derivative of x cubed is 3x squared. Plus, etc. The sort of generic term here, or arbitrary term, would be nx to the n minus 1. So we could write this out now as the sum. Now we've got to come up with a formula for this now. Now I can ignore the 0 if I want to. So let's start labeling this. Let's say this is well, we can either ignore it or not. It doesn't matter. All right. So for each one of these terms, notice what's going on. The coefficient is the same as the purple number. The purple numbers are my n's. So the coefficient is n. And then we get x raised to the, well, in each case it's n minus 1. And we go to infinity. Where do we start? It doesn't really matter if you start at 0 or at 1. If I start at 1, then my first term is going to give me 1x to the 0 power, which is this. If I start at 0, my first term is going to be 0x to the negative 1 power, which would give me that. So I can really start this at 0 or 1, doesn't matter. I'm going to start it at 1.